Welcome to Lab 2. In Lab 2, we are to observe the motion of a falling object. We observed the motion of the object dropped from rest that fell at a somewhat slowly pace straight down. We used Newton's second law to observe the effect of gravity and the drag forces. We were to model the effect knowing that the drag force is in the direction opposite of the direction of the object's motion. In this lab, I chose to use a fake lemon, which is just a plastic lemon with a hollow inside. I dropped it from head height until when it hit the ground. We uploaded the video into Tracker, as shown here. Once it was uploaded into Tracker, I set the axis. I put the origin of the axis at the center of the lemon. I set the axis so that the lemon would be moving in the negative y direction as it traveled downwards. I also created a calibration stick. I inserted the diameter of the lemon, which was 9 centimeters. I changed this to meters so that it would be more accurate. As in the last lab, we tracked the motion of the object. As the lemon fell, we tracked the motion by putting a dot in the center of the lemon or of the blur of the lemon as it went down. I chose to use frames 200 to 220 because that is when the lemon started at rest with an initial velocity of 0 and ended as it hit the ground with a final velocity of 0. The graph on the right shows the position on the y-axis compared to the time. The chart here shows that we went from time t equals 0 to time t equals 0.792 seconds. The initial position of the lemon, the final position of the lemon, and the initial velocity of the lemon were all equal to 0. As shown here, the final position is on the screen. We took the information and uploaded it into a Python shell so that we could model the information. I inserted and edited it so that it would represent the lemon. The mass of the lemon was 0.015. The initial position and velocity are shown here as the 0 vector. On the first time when we ran the Python model, the proportionality constant was equal to 0. While time was less than 0.792 seconds, originally the net force was only equal to the weight force, which is shown here. When this data was collected, I put it into a graph that is shown here. On the left-hand side, we can see the experiment position and the model position. This is using no drag force and only having the weight of gravity. This shows that the lemon should have fallen farther than it did if there were no other forces acting upon it. We then went back and added the drag force, which can be shown here. The magnitude of the drag force is proportional to the square of the object's speed, which is why the ball's velocity is placed in there twice. The net force is now equal to the weight plus the force of the drag. We also changed the proportionality constant to 0.0125. This was found by guess and check. When the model is run, we can see that the weight force pulling down is almost proportional to the drag force that's pushing up. And it is shown here on our model that it travels about 2 meters. Here we can see that the end position is negative 0.1899. This is very similar to the final position shown in Tracker, which is negative 1.89. This information was also put into a Google Drive. Here we can see the model versus experiment, including the drag force. The drag force is shown with the yellow line. This is much closer to the actual experiment data. This is because with the drag force, it gives a better representation of how far the lemon would fall due to the drag that is caused on it. It has similar starting points and ending points with discrepancies in the middle that could be due to user error of placing the dot in the center when the object was falling because sometimes it was blurred. The terminal velocity of a falling object is the velocity of the object when the sum of the drag force equals the downward force of the gravity. The net force is equal to 0 and the acceleration is 0. If the object were initially thrust downward, there would be an acceleration and the terminal velocity would not be the same. Overall, we can see that Newton's second law still applies when the object is in motion. The forces acting on the ball are the negative force of gravity and the upward drag force. The net force is still equal to 0.